In this video, I'm going to show you all three workflows for InfiniteTalk. As I mentioned earlier in my comments section, I told one of my viewers that I wasn't planning to make this video because the workflow is very resource intensive. But we don't really have a choice because we cannot deny the fact that InfiniteTalk is still better than WAN 2.2 S2V. Since I've already received successful feedback from 8GB VRAM users, I decided to share the workflow.
So why are we using WAN 2.1 instead of 2.2?
Good question. Basically, InfiniteTalk was trained on WAN 2.1. Now, WAN 2.2 does have better video quality, but the lip sync just isn't as accurate. And since InfiniteTalk relies heavily on lip sync, 2.1 is simply the better match. I already made a full WAN 2.1 setup tutorial, and honestly, the difference between 2.1 and 2.2 is really small. So if you need the setup, go check that video out.
Okay, then let's get into the big one. Why can some 8GB VRAM users run S2V just fine, but fail when it comes to InfiniteTalk?
Yep, this is the part most people get wrong. There are a few key reasons why 8GB cards struggle with InfiniteTalk. First, your model load must stay around or under 8GB. If it goes over, it's not going to run. Simple as that.
And that also means you're stuck with 480p output, right?
Exactly. No 720p, unless you upscale later. Next, your audio input has to be short. Keep it under 3 seconds, or it's going to crash or slow down dramatically.
And then there's the sage attention thing.
Yep, you must use Sage Attention instead of SDPA. Otherwise, it's going to take ages to generate. This is where most people give up, because Sage Attention is hard to install. You need patience to debug it, and it's not an easy task. A speed-up LoRa, like Light times 2V, is also very important. And set block swap to a maximum of 40 to keep the VRAM pressure low.
And all of this was already in your WAN 2.1 tutorial, right?
Yep. If any errors show up, everything you need is already explained there. InfiniteTalk builds on the same logic, just slightly heavier. In this video, we'll focus on how to set it up and which models to install for 8GB VRAM users.
All right, now let's talk about performance.
Based on the highest confirmed test we've seen so far, a 30-second video takes about 20 minutes to generate on an 8GB VRAM GPU.
It works, but yeah, it's definitely not ideal.
Exactly. If you want a smoother experience, I still recommend using a GPU with at least 12GB of VRAM.
And before we continue, here's a quick disclaimer.
Just because someone can run InfiniteTalk on an 8GB GPU doesn't automatically mean you can. It really depends on all the conditions we mentioned earlier, plus your WAN 2.1 setup and how well you've debugged everything.
If you want better quality, feel free to fine-tune the workflow. We're just sharing what has consistently worked for us.
And honestly, this whole setup is getting more and more advanced. Without some prior knowledge, it's going to be tough.
I think we've made that clear enough.
All right, with all that out of the way, let's dive right in. So these are the models you need to download first. First, you need to download the WAN 2.1 video model. I've put the link on the side so you can download it from there. Make sure you download the Q3KS GGUF version because it's the only model that's under 8GB. After downloading, place the model in the diffusion_models folder. Next is Light X2V. Make sure you download the image to video model. I'll stick with what I'm using, which is Rank 32. Put this file under the LoRa's folder. Next, we need to download the InfiniteTalk model. You can choose either Q6 or Q4, it's up to you. Download both single and multi because we'll be using them later. After that, place them in the diffusion_models folder. Next, we need to download the text encoder. Follow the link and scroll to the bottom until you see UMT5. Choose the FP8 model instead of BF16 because FP8 is only 6.7GB. I know most YouTubers recommend downloading BF16, and that's one of the main reasons why many people fail to load the model on an 8GB VRAM GPU. Place this folder under text_encoders. Next, we need to download the VAE. Just follow the link, download it, and put it in the VAE folder. Finally, download Clip Vision and place it in the Clip_Vision folder. Now let's move on to loading the image. Your input image needs to be clear and facing forward. It's best to use an image with a large facial ratio. This isn't a big issue until we move into the video workflow. I have two images for comparison. When the video starts, you can see the girl facing forward and her facial details remain consistent. However, when you look at the guy facing to the side, his facial details are no longer the same once he turns his head back to face forward. After uploading the image, the next thing we need to do is resize it. As I mentioned earlier, with 8 GB of VRAM, you can only use 480p resolution, so you'll need to crop your image to 832 × 480. After that, we're good to go. I believe most of you have watched my previous video where I talked about frame window size and the formula behind it, 4n+1. I'd actually like to share the theory behind it, but I've realized that most of you aren't very interested in the technical details. Since the frame window size is fixed by design, increasing or decreasing it will always follow the 4n+1 formula, so I'm not going to go into that again. Next is the motion frame. This refers to the overlap between two window sizes, which helps produce smoother video. It should be set between 9 and 25, so you generally don't need to adjust it. The key takeaway here is this. If you encounter a cuda out-of-memory error after loading all your models and the workflow stops at these nodes, one simple solution is to reduce the frame window size. I've tested reducing it from 81 to 65, which saves around 1 GB of VRAM. If you reduce it further to 41, you can save an additional 1 to 2 GB of VRAM. Keep in mind that lowering the frame window size will increase generation time, but it significantly reduces VRAM usage, making it a worthwhile trade-off. Also, don't forget to increase your block swap value to 40. I tested this on an RTX 5090, and here's the data. With block swap set to 40, VRAM usage stays around 8 GB. In the demo video, you can see that my initial GPU memory usage is about 3 GB because I'm multitasking. Once the workflow starts running, it spikes to around 8 GB. You don't need to worry about a brief spike up to 9.4 GB. That's normal and happens during model offloading.
I think we've made that clear enough.
So under the WAN video sampler, you don't actually need to change most of the settings because we're using the Lite X2V LoRa. You only need 4 steps. You can optionally change the seed by setting the control after generate, switch from fixed to randomize. One important setting here is the start steep. Keep this in mind. If you're using an input image, set the start frame to 0. If you're using a video input, increase it to 2 or 3. This helps ensure that the generated result matches the motion of the input video. Now, let's move on to the video workflow. It's the same as the single workflow, except I've changed the node from load image to load video. This takes the first frame of the video as an image to generate the video. Everything else remains the same. Just upload your audio and mix it with the video. Done.
I think we've made that clear enough.
Let's take a look at the multi-workflow. You need to switch the model type to multi before you proceed. As you can see, we need to input 2 audio files. For example, if I have an image of one boy and one girl, the first audio goes to the boy on the left and the second audio goes to the girl on the right. That's how it works. For the multi-audio type, there are 2 options. The first one is para, which stands for parallel, and the second is add. I didn't use add in this video, but let me explain how it works. Let's say I want the boy to say, "Hello, nice to meet you." This audio is about 2 seconds long, so I place it as the first audio. Then I want the girl to respond with, "Nice to meet you too." This second audio is added after the first one. In this case, you have 2 seconds of audio from the boy and 2 seconds from the girl, for a total of 4 seconds. That's why it's called add. In this video, I'm using the parallel type. This means both audio files have the same length. You mute the boy's audio when the girl is speaking and mute the girl's audio when the boy is speaking. Let me give you an example.
And all of this was already in your WAN 2.1 tutorial, right?
Yep, if any errors show up, everything you need is already explained there. InfiniteTalk builds on the same logic, just slightly heavier. In this video, we'll focus on how to set it up and which models to install for 8GB VRAM users. As a result, the final audio length is still 18 seconds, not 36 seconds. Is that clear? From the introduction of the video, I mentioned that we need at least 12 gigabytes of VRAM to run the multi-workflow smoothly, and here's why. With the frame window size of 81, GPU usage reaches around 13 gigabytes of VRAM, which is almost twice the usage of the single workflow.
All of this was already in your WAN 2.1 tutorial, right?
Yep. If we reduce the frame window size to 41, VRAM usage drops to about 9 gigabytes. But what's the trade-off?
And all of this was already in your WAN 2.1 tutorial, right?
Yep.
And all of this was already in your WAN 2.1 tutorial, right?
Yep. When we reduce the frame window size, lip sync no longer matches the audio properly, so the output isn't satisfactory. That's why I'm saying that 8 gigabytes of VRAM doesn't perform well in the multi-workflow. That's the end of the video on the 3 InfiniteTalk workflows. I hope you learned something from it. If you like this video, please hit the like button and subscribe to my YouTube channel. I've been quite busy recently, and I'll see you in the next video.